So the processes which we have discussed so far are what? Isothermal process, adiabatic process, then isobaric and isochoric processes. We have different set of regulations which are governing those processes, as if like in isothermal process the temperature remains constant, in isobaric pressure remains constant, in adiabatic process there is no change of heat from system to surrounding, etc. So if these set of changes are implied to a system, can system return back to its original state? Yes, it can, and that type of process will be known as cyclic process. So what is cyclic process? It is that process in which a system undergoes some set of changes and finally it comes back to its original state. And so there will, what would be non-cyclic process? It will be that process which does not come back to its initial state after undergoing some set of changes. So if I have to draw in terms of PV diagrams, PV indicator diagrams, a non-cyclic process would be something like that. Suppose I am representing a non-cyclic process which has come from state P1 V1 to P2 V2. Now we all know that what type of change this is. We have already studied about the expansion in both adiabatic and isothermal, right? So this is a case of what? Volume is increasing from V1 to V2, that means it is an expansion case. But the system stopped here, then and there at P2 V2. So what would happen? It is not going back to its original shape or original state. So in such kind of processes, the work done, so now what we are doing right now is we are calculating the work done in case of cyclic and non-cyclic processes. So in non-cyclic process, the work done would be the area under the curve. But consider another process. Now this time we are drawing a cyclic process where a system started from this point P1 V1, then it came to P2 V2, then it came to P3 V3, then P4 V4 and back to P1 V1. So these are four states: P1 V1, P2 V2, P3 V3 and P4 V4. I can also draw a simpler diagram for in this case. I can draw it like that. I am making it here. The state from here to here like this and here to here like this. Okay. So this is the state change. So similarly in this case as well, because I am going to do this same thing again in Carnot cycle, so that's why I am explaining this part. So if I have to calculate work done in a cyclic process, first of all, this part is going to get added up for the expansion. So this much part, right? And then the expansion from this to this. So this will also get added up. Now for compression, this part is going to get subtracted from this portion to this portion. That means this portion is going to get subtracted and this portion also, the compression case, is going to get subtracted. So what are you left with? We are left with the area under the curve. So the complete area which is encircled or enveloped in the curve of a cyclic process will give us the work done in case of cyclic process, whereas in non-cyclic process the only area beneath the curve is going to give us the work done. Alright.